Hello and good morning, grade 9 with you, Mr. Samir Awad. And today we are going to start our session about calculating the atomic mass of the atoms of the lesson 3, which is talking about the distinguishing between or among atoms. And today we are going to start with a little tutorial to know more how to calculate the atomic mass of any element in new time. And let's start by the tutorial today. And the tutorial today will be a video about 3 minutes, but as much as possible, we'll start to get it more. So if you get there, guys, you will get that the copper here you have to get about, two isotopes, 63 and 65. And the percent for each one is different. Accordingly, the 33 is getting to get 69.2% of its abundance, and its mass is 62.93 AMU, atomic mass unit. And on the other side, the mass for the 64.93 is getting to be 64.93 AMU, and its percent is 30.8%. So I'm getting here in the beginning to know what is known and what is unknown for us. The known one is the isotope itself and its mass and its relative abundance. Yeah, for each of them. First of all, guys, I have to start to turn the percent here into decimals, and that's what we will get. That's second step here. We can get it, guys. That's good. After that, after I get it as a decimal, I have to start to make what, guys? Yeah, I have to start to make my plan to calculate, and I will start to make that accordingly to multiply the mass times the percent decimal for both, and after that calculating them or adding them together in order to get by the end the mass of the copper itself. So that is the mass times the percent abundance in decimal give me for each one of them. Exactly. I'm getting the percent in decimal. Never forget, I didn't get the percent as it is. Like I divide the percent by 100 before I get it. That's to get it in decimal form. And after that, I add them together. It will be, 63.5 by the end. That is a good answer. So let's get to our sum now. Yeah, it's getting us the isotope of bromine in 79 and the percent for red, and also is giving us the isotope of bromine 81 and the mass and percent for red, and he wants by the end us to give him the atomic mass or to calculate the atomic mass. But first of all, which of the following statements is about the isotopes is true or false? Let's get faster, guys, to know about that. So in the beginning, isotopes are atoms with the same number of protons but different number of neutrons. That's exactly true. Yeah, because neutrons determine the atomic chemical, the atom's chemical properties. Isotopes of same elements very different chemically. No, first of all, because protons, not neutrons, and by the end, they are not different chemically, and that's not true. Because isotopes have a different number of neutrons, they have different mass number. That's true, and isotopes are chemically alike because they have the same number of protons and electrons. That's true. And isotopes have different atomic number because they have different number of protons. That's not true. Let's check the answer. I hope it's a good job. Yeah, excellent job. So if we get back to that one, if I want to get the mass for it, I have to make, first of all, the mass times the percent in decimal, and that's what we will do. 78.92, which is the mass times the decimal for it, which is 50.69, so we'll make it 0.5069. So that will be here for the first one, it will be 40. And on the other side here, if I get multiple the other one, it will be 80.92 times the abundance for it in decimals, which is 0.4931 now, and we'll get 39.90. And if I add them together, we'll get 79.90, and that will be the answer. Let's check. Yeah, that's a good job too. So let's get to the one, calculate the atomic mass for the isotope of chlorine 35, which mass is 34.97, and the other one, which is getting the abundance of 75.3. Yeah, oh, 0.7, sorry. So which of the following statement about isotopes are or is true? Yeah, isotopes of a given element have different atomic numbers. No, that's not true. They have the same atomic number. Isotopes of a given element have the same number of protons. Yeah, because they have the same atomic number, so they have, yeah, the same number of protons. Isotopes of a given element have different number of neutrons. Yeah, exactly. Yeah, isotopes of a given element have different mass number. Yeah, because they have different number of neutrons, they have different mass number. Isotopes of a given element have different number of electrons. No, they have the same number of electrons. So let's check our answers here. Yeah, that's a good job, guys. Let's again, last but not least, if I want to calculate the mass of the first isotope, I have to multiply the mass I get it times the percent, so it will be by the end what, guys? 26.50. And on the other side, if I get that, because the percent of it is about to be 25% in the nature or 0.25 in decimal, so it will be 8.965. That will be the answer for it. And if we add them together, guys, that will be 26.50 plus 8.965. It will be 35.465. And that's the answer. Let's check. No. How come? That's, I'm sorry, 34. It's going to be like that. 26.50 plus 8.965. It will be 35.46. That's enough, I think. Yeah, let's check. Yeah, they round up. If they round, it will be like that, guys. Yeah, I hope you get it interested today, guys, how to calculate the atomic mass for isotopes. And I hope you to be safe home. Was with you, Mr. Samir Awad, and I hope you guys good marks. If you want to ask any question, ask in the interactive sessions. And if you please solve all of your assignments on Pearson, and good luck. Bye-bye.